Okay, so once your synthesis is done, you should see a green check mark right here next to it. And then the next thing you want to do is create your UCF file, your user constraint file. So to do that, right click in here, select your source, select implementation constraint file. I'm going to call mine IPS underscore tutorial 22 underscore UCF. Hit next and finish, and it'll open up a blank file for us to write our constraints. So the constraints we are going to be doing is just mapping our input to a physical location and our output to a physical location on the BASYS2 board. So to get started on your UCF, you can Google master UCF and bring you to this link that has every single location and component available on your BASYS2 board. So here, if you look through this real quick, you'll see that it has all the clocks available, USB connections, 7 segments, LEDs, switches, buttons, PS2s, VGA connections. And then down here are your PMOD ports. So your PMOD ports, as you see, it says JA, JB, JC, and JD, which go with this JA block, JB block, JC, JD. And to address each individual component, so this pin would be location B2, and it goes with this pin right here, which is labeled B2. So if we wanted to take our input signal into that one pin, all we have to do is come back to our master UCF and copy that line, put it in our blank UCF, paste it in there, and then replace the net with whatever our name is. So our name of input is called signal, all lowercase like that. Now it says that signal is associated with location B2. Here you don't need the rest of the drive stuff, so you can add a semicolon and a pound sign to comment the rest of that out. Then the next thing you want to do is map your LED to its location. So going back to our master UCF, we can copy one of these LEDs. So I'm going to pick LED 1 here, so Control C, and paste it in our UCF file. So now we can change the name of LED all capital. Now we have associated the signal, input signal to location B2 and the output LED to location M11. So since we only have one input and one output, our UCF is all done, so we can save it. And we can go ahead and implement design. Double click on that, we'll get that running. It'll take a few minutes. In the meantime, I wanted to show you that under synthesis you do have additional options to generate a schematic for you. So as you saw, double click on that. And here is the schematic for the module you have just made. So as you see, this module we made is just signal going into an inverter and then going out to the LED. So we're just inverting the signal into and showing it to the LED. So our implementation is done here. We can go ahead and generate our program file. Program file will generate the bit file that we can program onto the BASYS board. While that generates, I will go ahead and plug in my BASYS board and turn it on. Alright, so go. Generate bit file is done, so I can open up my dep program here. Initialize chain, make sure we're connected to the right board, BASYS board. And I'm going to be programming the PROM setting, so you can select browse, but before you select that browse, you want to make sure that the blue jumper up here on the mode is set to the ROM setting and not to the PC setting. Once you have verified that, then you can hit browse and open up your bit file. Just a reminder, your bit file will save to the same location as this module saves at. So as you see for me, it's under my C drive, desktop, Project Lab 1, Verilog, IPS tutorial 2. So once I hit browse, I know I can go to on desktop, Project Lab 1, Verilog, IPS tutorial 2, and there's a bit file generated 1 minute ago, so that is the correct bit file. I can open it, and now I can program it onto the device. This will program it onto memory, so it'll erase anything on the memory and then let you know the status of the programming. It's done, so now we can move. So now that we have programmed the BASYS board, you can go ahead and turn it off and unplug the USB, and notice that nothing else is plugged in. When you turn it on, the first thing that you should see is that the LED M11 will automatically light up. So the program we just created, as we said, it was an inverter, so it's inverting whatever is in pin B2. So as of now, B2 is a 0, so therefore it'll invert it to a 1 and turn the LED on. To verify that the program is working before we enter the signal from the proximity sensor, we can plug in a VCC from any one of these PMOD ports. So each one of them has a VCC. Each one of them produces a 3.3 volts that we can input into port B2, and it turns off the LED. So again, it's an inverter. Right now we have a 3.3, which is logical 1. It gets inverted to a 0, which turns the LED off. And when we pull it out, there's a 0, which gets inverted to a 1. Okay, so our program is working correctly. So now the next thing I would like to look at is the signal that we're about to take into our BASYS board. This signal is going to be the signal showing on this multimeter here, and now it's off of this green wire. So this long green wire, I just plugged it into our voltage divider network, so the one we built a few minutes ago. We're just jumping off of this node right here. So I hooked up a green wire, long green wire, to that node. And now we can see that the voltage on the multimeter shows 3 volts because the sensor is not detecting anything. And when we put a metallic object in front of it, it goes down to 0. So 3 when it's not detecting anything, 0 when it is. Now we see that the signal, the wire we're about to put into the B2 pin, is off of the voltage divider and is a safe voltage to go into your BASYS board. But before you put any signal into your BASYS board, you want to have a common ground. So I will ground the PMOD port I'm using to the breadboard. So that'll give us a common ground, and which will allow us to input our signal to pin B2 here. So notice as soon as I plugged it in, the LED turned off. That is because now it is directly connected to the sensor over there, and it is inverting the signal coming from the sensor. So if you remember, the sensor was putting out 3.3, which is logical high, which gets inverted to a 0. So now, having everything plugged into our BASYS board correctly, you can see that as the sensor detects a metallic object, the LED on the BASYS board does turn on, which means we are recognizing the signal from the sensor to the BASYS board. From here you would make a module to tell you which direction to turn the motors, to follow the appropriate path, but the rest of this is just code and logic, and I can show you how to work with that once you are ready. But for now, this is the main part of this project, was to show you how to input the signal coming off of the sensor there, input it into the BASYS board, which can be difficult because you do have a high voltage signal and you don't want to take that high voltage signal into your BASYS board. Okay, I hope you learned something. In the future videos I can demonstrate different other things, or you can reach out to me and I can help you personally.